So welcome everyone to adopting CDEvents and embracing interoperability. Thanks for joining today. My name is Andrea Frittoli. I work for IBM. I'm an open source advocate. I live in Wales, UK. It's very windy, so I couldn't find a picture of myself with my hair straight until I decided to cut it. So I'm a CDEvents maintainer and co-chair of the events special interest group we have within the CDF. And I'm also involved in the CDF. I'm the chair for the technical oversight committee and member of the governing board. So yeah, today we'll talk about CDEvents, introduction to what it is, the project. I will present what's new since last update we did, I guess, in CDCon last year, or well, no, in Detroit last year. We'll discuss about the adoptions within tools and show you some roadmap, what we're looking forward to implement in CDEvent next. And then I'll thank you. Okay, to introduce CDEvents, let's start with a pretty standard continuous delivery pipeline. Sorry about that. So where you have started with an SCM, like your GitLab, GitHub, where you have your code, and then you go through build, test, signing, you produce some artifact that is stored in an artifact registry, and then you have some deployment phase that finally goes into production where monitoring kicks off. And this may be the pipeline simplified for a single artifact, but if you have more than one artifact that you're producing and more than one team, so you may end up in a situation like this where you have maybe more than one SCM tool being used. You certainly might have multiple build steps and design. Sometimes with different tools, you have different deployment approaches. And if you have to build integration between all these different tools, it becomes easily too complex to maintain. Or you don't want to have all this integration point to point between the different boxes. So there are a couple of approaches you can use to simplify this. So you could think of using some kind of orchestrator, central orchestrator. So this orchestrator can drive your different tools through events or through API. And then you only need to have this interface between your orchestrator to the different tools. Still, you have some complexity then that is centralized into the orchestrator because the orchestrator becomes kind of the bottleneck. It needs to be aware of all the different tools, and if you add a new tools, you need to build this interface to the orchestrator, and you need to, basically define the whole logic there. Another more distributed approach that you can use, still combined with events, is something more like choreography, so where you have the different tools sending signals about what they're doing and the other one reacting to that. So in the case of orchestration, you have, for instance, the director that is sending signals to all the musicians, and they all react to that. In the case of choreography, every dancer will send signals, will do certain movement, and the rest of the ballet will move accordingly. So you can do similarly with tools. And that's kind of what we try to do with CDEvents. If you look at this scenario of choreography where you have different tools talking to each other, it makes it much easier if they speak the same language. So with CDEvents, we define a common specification for events in the continuous delivery space, so that tools in this space can talk to each other. And if you introduce this kind of concept, then the architecture will look more something like this. So where you have the different tools, the different stages that we had before in the diagram, like your SCM, build, test, design, deploy, monitor. But instead of each of them talking or triggering each other directly, they will basically declare what they are doing for events. So your SCM system will say, well, there was a PR merged into my code. Or your build system will say there was a build started or a build finished successfully or unsuccessfully. And they can do that all using a consistent shared language, which is CDEvents. And they can all send these messages to a broker. And then you can have components that apply certain policies to this event and allow to trigger the next step in your workflow. Right, so this is basically switching from integration to interoperability type of scenario. But there are still some issues when you do this kind of setup. What about observability? Right, because when you have this event-driven approach with different components and declaring what they're doing and applying policies, but in this distributed format, it becomes harder to answer questions like, what is running right now? Where am I in my workflow, right? What steps were executed? And if something goes wrong, where did it go wrong, right? So you need to pinpoint where things went wrong. It becomes harder to answer questions like, how long did it take? So you may want to evolve the picture before it add some more blocks in the bottom. So starting with the store one, so you can send events from all the different tools and then send them to the broker, and the broker will collect them all in a single store. And that has multiple benefits. First of all, you're building an incremental state of your workflow in that store. And when you take decisions in your policies, you can also look at that to decide what to do next in your workflow. And the other thing, you can use these events that you're collecting to do more things like providing, for instance, a view of your workflow across the different tools in your workflow. So you can build some kind of interactive view that will display your build or the life cycle, for instance, of a change from when it was committed to when it was built into an artifact and then deployed to production, and eventually any incident that might be associated with it. The other benefit of collecting all this data and having it in a consistent format stored is that it allows you to crunch the data, do analytics, and build metrics. So some metrics have been quite popular in the past years, like the DORA metrics, where you measure a certain aspect of your CD processes, like how much time does it take for a change when it's written to get to production, or how often do you deploy to production, and those kind of metrics. So if all your tools in your tool chain are able to produce events in a consistent language and you can collect them, it becomes much easier to crunch, to calculate this kind of metrics out of this data. Other things you can do is like send notification, for instance, to improve visibility, observability for your users. So to summarize again, why would you want to consider CDEvents? I mean, the main idea is interoperability. So in the two use cases, event-driven workflows that allows you to build like more scalable architecture, decoupling the different components, the different tools. It gives you a lot more flexibility. Consider the case where you have certain logic built to calculate metrics or to visualize your pipeline, to take decision based on certain information, and this information is coming from a certain tool that you're using for building. Now, if another team comes in that use a different tool for building, but the tool generates events that speak the same language as the other tool, that you don't need to change anything else in your system around it. So it will still produce the same format of information, so you can continue to use the same policies and the same visualization tools to get everything working. And the second use case is observability, so the ability to have an overarching view of your workflow across the different tools to build metrics and notifications. Okay, a little bit, taking a step back, a little bit of history where CDEvents comes from. So we started discussing about a standard for events within a special interest group within the CDF. So we had one interoperability special interest group, and then an event special interest group was created out of that. So we discussed about the need for standardization in this space. And out of that, we created the CDEvents project. So the first commit was October 2021. And then with the help of CDF, the project grew and it was incubated in the CDF in 2022, so last year. And also last year in November in Detroit, we announced the first release, the release 0.1 of CDEvents, which supported events for orchestration, software configuration management, CI/CD, and also it included things like a Golang SDK, a cloud event binding, and support for some DevOps metrics. So I want to discuss what happened since then. So since last time, since November last year, so we worked on a number of few things. We made a couple of new releases, so 0.2 and 0.3 was just released last week with some interesting features. So we expanded the scope of CDEvents to continuous operations. So we introduced incident type of events. And so the idea is to extend this automation to when software runs into production. So not to stop from like deployment and job finished, because your changes that you created in your SCM and it was built and deployed actually continue to live in the production environment. And so you may have incident associated to that. So we wanted to expand the data model into that space as well. And that allows us also to then provide enough information to calculate the remaining 2 DORA metrics that were not covered in 0.1 release of the protocol. Incident events also help with automation for remediation, because if something goes wrong, if you have an incident, then you could do things like automatic rollback, or you could use this information in general to trigger automatic remediation. We also had new contributors to the project, the TestCube project. So they contributed a revamp of the test events, which can be used for test-related automation. We introduced event in the area of software supply chain security for artifacts signed. So the idea here is that for instance, if you're building a container image and you're signing it, like you can do with cosign or with Tecton chains or some tool for signing container images, to send an event when the signature is actually produced, so you can react to that. For instance, specifically in Tecton, we sign our releases and we want to produce the release notes and publish the release finally only once all the artifacts are signed. So that's a use case that it was interesting there. So we did a few quality of life improvement as well, improved the readability of the spec. We added examples for each of the events in the specification, and we refreshed the website as well. We did a lot of work on our SDKs as well. So we started with a Golang SDK. We added features like JSON validation, so you can validate all the incoming events through JSON schemas, and you can also validate produced events. For the Golang SDK, it's now generated also from the JSON schema directly to improve reliability. We improved the testing as well. So we have the Golang SDK version 0.3 released, and we had a lot of work happening also on the Java SDK and the Python SDK. So we have an initial version of the Java SDK that was published onto Maven Central. And so also here we had a lot of help from our Fidelity that joined the project and helped us a lot there with that. And similar for the Python SDK, so we have a first release soon to be released and to be deployed on PyPy. So the other thing that we worked a lot and we made very good progress on is adoptions within the tools. So CDEvents as a project is basically a specification and a collection of SDKs. But it's only as good as it is adopted by several tools in the ecosystem, right? And so adoptions that we have today, now with the new version, is with Jenkins. So there is a Jenkins plugin, which is published to the Jenkins official plugin repository. And thanks again to our Fidelity community members for contributing that. So it is possible now to produce CDEvents with Jenkins. We have experimental support in Tekton, so you can produce CDEvents from Tekton, deploying a specific controller for that. We worked a lot with the Spinnaker community, so we have an RFC approved and implementation is starting that. And as I mentioned earlier, we work with the TestCube community as well, so we just released now the new version of the test events, so they are starting to implement these in their tool. We are having a lot of discussion with other communities as well, so we talked to Argo, Flux, Harbor. Harbor, they announced in Amsterdam a couple of weeks ago support for cloud events, and they said they would be interested in then extending that to CDEvents specifically as well. Other projects interested like Trace Test, JReleaser, we are discussing with Shipwright, Nginx. So things are moving quite a lot in this space. And I wanted to provide some more details and examples from some of the tools that we're integrating with. Sorry. So for Jenkins, today we can produce then CDEvents through the Jenkins plugin. So combined with the pipeline plugin, we are able to produce events from the core group. So when you're running a Jenkins plugin, you can generate a pipeline run, queued, start, and finished type of events that can be delivered either to syslog for testing or to syncs like Kinesis or HTTP sync, right? And the next step for the plugin will be to then support ingesting events as well. And so once you're able to do that, then you could have different tools, different teams, or different type of triggers sending CDEvents to trigger a Jenkins pipeline, and then generating CDEvents. So you could even have Jenkins triggering Jenkins in a kind of flow like that. Spinnaker instead is focused more on consuming events as a starting point. They have a very good infrastructure for webhooks, incoming webhooks. So we started with the RFC today covers consuming events, CDEvents, as input to Spinnaker pipeline execution, basically. And the next step there will be to produce events as well. But yeah, we built like some POCs with combining Tekton, Jenkins, and Spinnaker, where Jenkins and Tekton are producing CDEvents, and Spinnaker are consuming those to start a pipeline. For TestCube, you could imagine producing test events. You could take decisions, apply policy based on what is happening in your test suites, and decide, for instance, that you want to notify someone that has to look at a certain test that is failing. Or if you're running some smoke test in an environment after a deployment, you could use that and send that to your deployment automation, again, to do some more automation, decide whether you want to keep that deployment or roll back. It is also useful, can also be useful for collecting metrics, again, if you want to have history over time about your test execution. And in terms of Tekton, well, Tekton provides a component called triggers, and that kind of natively supports ingestion of cloud events, although any event that is JSON over HTTP. So it kind of natively supports cloud events as well, CDEvents as well. The pipeline component from Tekton also can produce cloud events today, and we have an experimental controller that can be run next to Tekton controller to produce CDEvents specifically. I also built like a toy project that I called CDEventer that basically allows you to get incoming event from triggers using the trigger functionality to extract information from that and then produce a CDEvent as an output. So you can use triggers together with CDEventer as a kind of adapter layer to transform events of a certain format into another format, which is really nice and useful for building POCs. So what did we learn working with all these communities and integrating into tools? Well, one of the questions that I think maybe the one that I got asked more is, okay, so we can get events into the tools, but how do we combine the tools? So what is the reference architecture? So this is one of the main questions that we got a lot. And also what the event broker looks like. So for the POCs, for some of the POCs that we built, we use something like Knative eventing because it can broker cloud events directly, but not everyone has Knative eventing their system or want to run it anyways. So these are kind of areas that we are discussing and addressing today. Another area which was easier for Spinnaker but harder for other projects is like responding to events. So okay, I get these incoming events, but what do I do with them, right? So you can store them in a storage. You can try to take decision in real time on them, based on them, but there is no guideline at the moment on how to do that. So we have some implementation. There are some implementation happening, but we don't have, again, a reference architecture for that. And there might be space for some new component to exist in open source that would allow us to standardize the way we do that. So if I go back to this diagram, basically where I got the policies and triggers kind of component, we could think of including something within CDEvents that standardizes or provides a common tooling for doing those parts. Another lesson learned is do incremental adoption. Do not try to get the whole CDEvent spec into every tool at once or receiving and sending events. Do it one piece at a time, and also work with the community. So it's always good for us from the CDEvents project to go and join working groups from other community or meet people at the conferences and discuss about the use cases and what makes sense for them why it would make sense for them to include CDEvents and work in the initial step of the adoption. In terms of SDKs, we made our nice experiences of having documentation not consistent with JSON schemas or not consistent with the SDKs or what is produced because we started doing things manually, so we learned that we should really generate things automatically, and that's what we are working towards. So generate the SDKs from the JSON schema, generate the documentation as well from the schema, so I have a single source of truth. And also, there's been interest in having more languages supported, like JavaScript and Rust, so hopefully we'll see those SDKs in future. So we got feedback as well on the specification, so it's important to have examples, and we built a lot of examples now in the specification, but as CDEvents start being used in the wild, so we want to create more extensive catalog of examples of CDEvents produced or that can be produced or consumed by specific tools to make it easier to adopt it. In terms of community, we are collaborating with several community. I'll talk a bit more about that in a moment. So what are we going to do in terms of roadmap, what we're looking for the future, so for version 0.4 and beyond. So we definitely want to work on more supply chain security type of features. So today we added the artifact sign type of event, but we want to be able to capture more information about artifact and software supply chain security aspect of artifacts, like SBOM, attestation, provenance, and those kind of information attached to events. The other bit, which I think is probably quite important for CDEvents to implement, is the ability of signing events, because there are a lot of use cases where you may need to trust, or you may want to trust the content of the event before you take any kind of decision based on those events. You need to be able to trust them. And so we will need the ability to assign events. Features that we've been working on that hopefully we'll release in 0.4. It's native support for correlating events with each other. So in CDEvents, we have this concept of subject and predicate. So you can have a subject, maybe like a build, and a predicate. So it's like a build is started or stopped and so forth. And subject have IDs that can be used then to correlate different events within each other. But we want to have more explicit support of this kind of correlation to make it easier if you have a data store with a number of events to, let's say, extract all the events that are specific to a certain workflow that happened in your CDE system. Or if you want to trace everything that happened with a certain code change or everything that happened with a certain artifact. And so we're building features like links or workflow of IDs, composition, and concept of releases to enable us to do that. In terms of software features, as I mentioned, we want to extend the range of SDKs that we have. We're working on some adapters, like for translating existing events into CDEvents as a way to, while CDEvents adoption grows. And we want to build more proof of concepts. And possibly, as I mentioned earlier, maybe do some work in the area of like providing some guidance and maybe some software in the area of the broker and the policy. Other than that, from the documentation point of view, we want to work on collaborate with reference architecture initiatives and provide more example events and implementations. I mentioned a few collaborations that we are doing. So within the CDF, we have one special interest group which focuses on best practices. And they have this reference architecture initiative that I mentioned a couple of times. So we are collaborating with the best practices SIG to get CDEvents part of the reference architecture there. Also, we met with the CNCF tag app delivery in KubeCon a couple of weeks ago. And they are very interested in this kind of standardization as well, having a kind of standardized data model that you can use across the delivery of application. And that's a very good overlap with what we do in the CD space. So we already had an initial meeting with them, and so we are trying to find out how we could best collaborate. So one of the things that the app delivery group produced is this potato head sample application. So perhaps one of the discussion was maybe to produce a version of that relies on CDEvents to use it as a showcase of how to use events in this kind of context. We are also having interesting conversation with the VSMI group. It's Value Stream Management, Interoperability. It's a group within the Oasis org. They care about interoperability between tools that work with value stream management. I don't know, your Jira or those kind of tools. And again, their scope is a bit wider than we have in CDEvents, but they don't want to reinvent the wheels for areas where a standard already exists. So we are trying to work together, so they can potentially use CDEvents and help us grow it as a standard. I think I mentioned most of these in the community. I mean, in terms of contributing company, we have Ericsson, IBM, Red Hat, Apple, VMware, Fidelity, SIS, and more people contributing. So it's growing, and everyone is welcome to join and contribute. We are growing, but we are still also at 0.x version and early stages. So it's a great opportunity to also join us and kind of contribute and influence the direction of the project, right? And there are so many areas where we're looking for contribution from the specifications. We're more like high-level discussions where we want to go with the specification, but also like building SDKs, tooling, proof of concepts, and so forth. And of course, adoptions. And yeah, that's all I had for today. So thank you again for joining me today. I got some references here. And yeah, if you have any questions. Yep.
So can you give a contrast between CDEvents and OpenTelemetry in terms of, it seems like CDEvents is focused on application delivery, OpenTelemetry is focused on observability, but there are overlaps. Any insights?
Yeah, that's a great question, and we have some threads going on also through the app delivery tag, because they're also involved with OpenTelemetry, so we've been talking about this. I mean, CDEvents is defined as a specification. It's kind of transport agnostic today, and we have one binding that we've implemented in our SDK, which is Cloud Events. Cloud Events is a CNCF project that standardized the format of the payload. So you can basically transport a CD event in a cloud event, right? And the CD event is going to be a JSON blob that you put into the payload of a cloud event. But from a CD event point of view, we are not really constrained to cloud events. So one idea possibly could be you could transport CD events on top of OpenTelemetry type of protocol as well. Or you could discuss what part of the data model can be shared, how they could complement each other. But yeah, that's a very good question. We definitely don't want to create like competing standards in this area, so we are starting this conversation. Any more questions? All right. Well, thanks for coming again. And yeah, enjoy the rest of your conference.